My name is Sahil Soni. I am principal AI architect, and as part of our series, this is our video 2. We are learning here how to make AI agent safe in an enterprise production level. Why? As part of our last series, we learn why 90% of AI agents fail. Here we will learn how we can make it better. So now we see that why agent fail. Now let's talk about what actually fix it, right? Fixing is important. So everyone is building smarter agent with newer models. uh, Google is releasing every other month newer model, but I am making not smarter agents, I am making safer agent. Again, all this failure happen because the system trusts a probabilistic model to make deterministic decision. What that means? As we learned in last lecture, LLM is a probabilistic based model. If you ask it what is 1 plus 1, it will go check it weights based on probability, it will give answer. And if you flip a coin, its probability can be 50-50. If it's going to rain, probability can be 90%, 99%. It's never 100%. Same thing, these LLM agents, they are smart, but still researchers are trying to learn how to activate those neurons which always give better results. More research is going on, so that's why we say LLM are probabilistic based model which cannot make deterministic decision. What is deterministic? They cannot make if always 1 plus 1 is equal to 2. If you give it wrong prompt, 1 plus 1 is equal to 3 in alien language, you will start making those decisions. So now that's interesting, right? Means you were knowing it, right? LLMs are smarter. Yes, they are smarter, but they are probability based model. Remember, machine based probability based model. You learn in your math which make deterministic decision. We ask them. So we see. Anyway, let's go to next chapter, the core insight. As part of our series, we will not deep dive our last slide. We will do it as part of next series. So on to our solution about how to make LLM agent safer. We saw in our last demo, if you use prompt based safety, this don't generate drop statements. Again, it's our probability, right? But production requires guarantee. That mismatch is the root cause. Now you know why my demo failed. LLM are probabilistic based model, and I am asking them to work on production. So what's the solution? We saw this prompt based safety again as part of our last lecture, how agents can alert log and it drop RMAN backups, right? Just refresher for you guys. Now the solution, yes, solution is structural safety enforced by architecture, not prompts. This is interesting, isn't it? How we will enforce structural safety which on architecture, not on prompts. I want to learn it, I want to say it, I want to implement it my agents. No matter what my agent is, I want structural safety. Learn it and it will be helpful in your job, getting a new job. Ah, so what it is structural safety? So if I define it in math function, S is structural safety, F is function, you have action, policy, contact. It take three parameters and the out, allow, block, escalate. This math function is the core. How? Because structural safety is now not a probability. It's not a probability now, no more. It take action, evaluate policy and context, what my policy is, what its context is, and return a binary decision, allow or block. No ambiguity, no false statements, no hallucination. So you saw, if you know your domain, if you know how to work on your agent, if you know what problem you are solving, you can create those policies which make these binary decisions. That's why structural safety is not domain specific. It's the heart of agents. So what is the action? You know what's the action? You run a LLM will run SQL statement as our example of Oracle DB, API call, config change, MCP call, calling Excel, calling PowerPoint, anything. What's policy? Environmental rules. Don't run production changes middle of day. What's the blast radius? Drop database, drop table, run a market campaign on a holiday. Don't run a market campaign on working day. Right? These things you don't want to run Amazon market campaign on Amazon when you have ball game. That's policies. What's context? Current state. What's the current state of environment? Time of day, concurrent operations, failure history. If you are running a action based on a policy, whether that environment, whether that production DB is really at that time is available, how much busy it is, if it will change its state, you need to know all this, right? That's why I say context, current state, environmental time of day, how many operations you will do, how many calls you will go to 1,000 customers, 5,000 PDFs, what's the failure history out of those 1,000 customers, 50k PDFs, all these things. Anyway, yeah, this is getting interesting. This is math. Do you like math? If you like, thumbs up, drop comments. If you're listening, of course. Boring guy like me. Anyway, so what is architecture? This is again the heart, which I say structural safety, which we base upon the math, right? LLM create JSON output. Why JSON? We always want it to be in JSON format, so it don't create garbage output. That's very much important. Very much important. JSON output. LLM should always generate JSON output. You don't want garbage, no matter what your agent is. After it generate whatever you ask it, SQL 1 plus 1 2, get my latest market data, run my ad, get my latest stock information, whether Google will go down or not. Based on its output in JSON format, we have a LLM judge. Let's take example of stock here. LLM generate based on market condition. Let's trade a stock of Google, it will go up. LLM just say no. There is a EU case which is pending. I am don't do that. Then you have safety mesh. How about safety mesh? Checks in the rack in your news verifications, policy gate, blast radius, circuit breaker, rollback check. As in our stock example, what is rollback? Don't do trade. Circuit breaker, don't keep on doing trade. Blast radius, whether you are doing 100k, 10k, rack verification from the news, documentation, their gate sheets, policy gate. What's the policy you have, whether you want to do options or stocks. This is for finance people which do trades, and in our DB example same. Generate a SQL, verify SQL if it's right or not, Gemini, GPT-4, other model verify, safety mesh, whether it's RAG checks, whether it's right syntax, 19C, 12G, blast radius, production environment, whether it's same SQL drop data file you are running, how many times, roll back there, drop data file, add data file. This is interesting, right? Now you are coming out of probabilities to safety mesh. Now you are in control. Agent is not in control of your environment. That's what we want, right? Now you learn the hard part. Now the safety mesh 5 checks, again the policy checks, the prod environment we already talked about, whether you want to run a SQL prod outside maintenance window or not. Conflict, 2 agents on same DB, one say add data file, other say kill session, they are in queue. That's our conflict detection. Most people fails to code this in their agents. This is again very important. Conflict detections, blast radius, drop table, high risk, block it, create table, okay that's fine, new table, create view, that's fine, no drop it, circuit breaker, 3 failed fixes on same DB, excellent. Why so many fixes I am doing on a DB? Add data file, kill a session, kill a blocker, right? Anyway, next rollback, again add data file, add if you are doing, if you are doing a kill like session, if you are doing add column, it's rollback and accelerate. This is easy for you, right? This picture is clear. Non-bypassable by design. So what that means? That means in you all of your work in production environment, you know sandbox. So LLM lives in sandbox. Yes, that's the way to understand it. LLM lives in sandbox. No matter what you do, it will not break your production. Right? After LLM execution happen, safety mesh. Model physically cannot execute anything without passing validation. That's why execution requires validation. No code path from LLM output to execution that bypass this mesh. Again, we are repeating same thing again and again. Safety mesh. LLM is just a sandbox. It no whether it's LLM as judge or what. It's not the final authority. It's your rules, your policies as a domain expert. So what's the key principle? I'm again saying LLM as optimizer, no decision maker. LLM generator exploits, get SQL, LLM just optimize, safety mesh enforce. I have seen so many people ask me same question. If it's LLM judge, it's not production. That's my answer same. It's not the LLM judge which make decision. It optimize it. Multimodal scoring panel, same probability base. Out of 1 to 100, what's the probability? Final decision, allow, block, escalate. Binary based decision, JSON output, your rules, you rule. Right? Time for a demo. I promise you I will show you in my next video live demo of Sentry for Oracle DB. So now this is slide which we create based on demo. We want to someone run a drop table, just say score 92, plug it. That's it. If it's create or replace view, just say 0.61, 0.51, okay, run it. Safety mesh, you are replacing view, block it. Blocking session, just say kill it. Safety mesh, you are blocking a sys or sysdba session or session middle of day, escalate to human. Whether he want to kill or not, in the end it's his DB. You are not, agents are there to help. So now you are feeling that, right? With this safety architecture you are in control. Feel power, feel it. JD the power. Anyway, human in the loop, we cite mesh block action. It can be Slack, Jira, not again in my current code I have only notification via email. If I get reviews, people ask me, I can do Slack, Jira integration, DBA preview, approve, reject. But again, you are doing your own agent, make sure do your integration, or you're doing on email, you can use my code. It's easy. Anyway, same repeating things, original alert, investigation finding, all candidates fixed with judge scores. Again, this thing not only specific to DB. I give you example of finance. It's not, you can do on cloud. You want to do cost voucher, you want to terminate your Kubernetes instance based on resize. Your Kubernetes has some issues, you want to see, you want to take some action, you want to have a bigger instance, you have a security incident, you want to block something, you have a security incident, someone try to do DNS attack, you want to block IP, it take action. That's your chance, show it. DevOps, GitLog, you deploy something on using GitLog, you deploy some pipeline on dev beta staging, it runs fine, but it on prod it blocks because you don't have resources, you don't have permission. This is the agent. You don't need, at least in my environment, in my software I have shown until now, it works as a perfect L2 Oracle DBA, and I promise this year we'll make it L3 for SQL tuning and RC acceleration. Going forward we have a plan for L4 and L5. Don't miss it. So now you know, if even if LLM hallucinate, even if judge fails, even if you get prompt injected, safety mesh, my friends, safety mesh. Same, just repeating to make sure you don't miss it. LLM explore, judge, mesh enforces. Mesh enforces don't confuse optimization with safety. What's next? Slide 3, we'll see how we enforce policy. We have a solution now. How to implement it? How to make agent environment aware? A RAG verification. Why we need RAG? You have policy. Why I need RAG? What is RAG? LLM Judge. This thing we will talk more details, technicals, and again safety mesh, how this all works together. So now that we understand the architecture, next video we will building it step by step. What we will build?